Okay, let's start with our preferred subject, firmware updates. And our Hadoop cluster. So a bit of context. Our Hadoop cluster, that's kind of the most important thing that we have at Criteo. That's where all our data is, and that's where we train our model. If the cluster goes down, well, it's going to be a bad day for everyone, and especially for us in the infrastructure. In 2018, we had an advisory from SSD vendor. Advisory was reading something like, in rare conditions, a premature wear out, update to the latest firmware. Okay. Our Hadoop name nodes, so the index server, they have like 6 SSDs. And at the time, we had automated monitoring, hardware monitoring, but we didn't have good dashboarding capabilities, so we had to kind of manually check. And when we checked, we discovered that about a third of the SSDs on this server had already failed. But there was redundancy, so it can't really be that bad. But the firmware update thing seems to be important. So what we try to do, let's go. But Hadoop orchestration is hard at a large scale. All operations take a long time. Switching a name node, that was like a day operation, and rebooting the whole cluster was like weeks, several weeks. We didn't have any automated action for pushing firmwares, so we were doing it by hand at the time. And often, because it was taking weeks to reboot the cluster, we updated the firmware and we didn't reboot the server explicitly for the firmware. We were just waiting for the next update reboot cycle. You see where this is going. So the decision was taken because we were updating the firmware. Let's not just update the SSD firmware, let's update all the firmware. It's simpler with the hardware tooling from the vendor. Of course, we tested in pre-prod. One server went fine. Rebooted it, everything was okay. So let's go to prod. You only live once. There was a slight misunderstanding with the people that were actually doing the update. They didn't understand that the update was supposed to run only on the name nodes. They updated the whole cluster. But again, what could go wrong? This is fine. Of course, a few days later, we were pinged. Rebooted nodes were not coming back. Like every single node rebooted were not coming back. So what we did, we dig in a little bit, and technically the nodes were rebooting. But once they had rebooted and the OS had started, there was no network. And so what do you do in this case? You go to the kernel console and you look and you see this little message. The EEPROM is corrupted. Everything is fine. So it's only the Hadoop cluster, and it's only all the nodes in the Hadoop cluster. What could go wrong? So what we did, we tried to get more detail. So we discovered that all the affected nodes were running a specific kernel version. Too bad, it was the one we had on almost all the cluster, except the nodes in pre-prod that we tested, which were running a more recent version. And so we did a quick diff, and we discovered this commit in the driver for our network card, and avoid NVM acquired deadlocks during NVM update. And when you read the message, this resulted in a corrupted state. Okay, we have a winner. So, situation assessment. In a case like that, you do assess the situation. All NIC in the Hadoop cluster are soft bricked. That's bad. If there is a power loss, it's going to be fun. But the cluster is still running fine. So it's good. The netboot was still working, so. And update from a fixed kernel were repairing the NVM. So you see where this is going. Of course not. We are failing with style here. Let's live patch the kernel. I haven't said in which category we are. Is it win-fail? Is it fail-win? We will see. So the kernel has live patching capabilities. Let's make use of them. But we haven't compiled them in. So, who needs that? We have the ftrace infrastructure. So let's write a custom kernel module, which has all the code from the fixed version of the update function, which resolves the external references in our live kernel to the functions of the driver that are, the bad ones, and let's patch them. And of course, because we have learned from our mistake, we deployed this kernel module in a progressive rollout fashion. And we saved the kernel, we saved the cluster like that. So it worked. So it's a fail win.
So did you enjoy this concept of Prem'Fail? Should we do it again on the next editions? Okay, it's a good yes. I'm happy to see that I'm not the only one to have strange ideas.